which has its final part on Saturday morning. If you like what you experience here, then please do tell others about Aim High, and please join us again. Feel free to ask questions as we go whenever you'd like to. There is no such thing as a stupid question here, and please never feel that your question will be distracting. We are used to selecting questions from a torrent as we go. Any questions that we miss, we'll be happy to come back to at the end, and please also feel free to respond to one another's comments and questions as we go along if you'd like to. Please check that your chat is working now by typing if you think you could or could not, or have at some point in the past been able to balance an egg on top of another egg. Type your what you think now. Okay, so today's Aim High lesson welcomes a very inspiring guest whose work as a geographer and then teacher led to her leading all-female sailing expeditions to explore the ocean, further our understanding of plastic pollution and campaign for change. We still don't know most of what there is to know about the world, and it's people like Sally who have made some seriously brave and selfless life decisions to uncover the truth, tell the world about it, and bring about change. Most of activism isn't super famous people on Instagram. Most of it is the work of incredible human beings like Sally Earthrowl, who deserves to be famous, I think. Sally, it is great to have you on. Thank you for coming on.
Hi. Thanks very much for that amazing introduction. You've made me feel very special on a Tuesday evening. Right, I shall get going. So yes, as I've been introduced, I have moved from being a teacher to an adventurer and an ocean advocate, but I've actually always been a little bit adventurous, as I'm sure my parents would explain. But I moved in 2015 to go and live and teach in Indonesia. And that's not what most people would choose to do, to move to the other side of the world, to go and follow their passions. And it really was a geographer's paradise living and teaching on a tropical island with volcanoes and earthquakes and coral reefs to go with it as well, alongside tropical rainforests. But today I'm going to talk about my journey and how moving to Indonesia actually led me to, as Matthew said, going out into our oceans and finding out more about the environmental cause that I care a lot about, which is ocean plastic or plastic pollution. But plastic pollution tends to start on land. So like my journey starts on land, I wondered, can you put in the chat what percentage of marine litter is thought to come from land? So we all know there's plastic pollution. We all know it's out in the ocean. What percentage comes from land? Is it 50%, 60%, or 80%? What do you reckon? You can put it in the chat, and I'm sure Matthew will let me know what you think.
So there's a few moments of delay as people say, but okay, so like, when you say not coming from the ocean, not coming from the land, do you mean like shipping boats and stuff like that in the ocean?
Yeah, so some part of our shipping boats, so we've got a certain amount of plastic out in our oceans. Some of it comes from fishing and the shipping industry. Ultimately, all of it comes from land, but which comes from loose from land, where it hasn't been managed properly and it's made its way out down our rivers, across our winds and out into the sea.
Okay, Ray thinks 80, Henry thinks 60. We're getting a mix of 60s and 80s.
Oh, well, I'm sorry to tell you, it is 80%. But the reason why I put this on here is that 80% of marine litter is thought to come from land, but 80% of that marine litter is thought to be plastic. And we know that plastic is an amazing material, but it is designed to last forever. So this becomes a bit of a problem and the reason I put this here is because I'm going to spend most of today talking about the scientific research that I've done out at sea. But I want us to remember that the solutions happen on land with us. So have that in mind as we're working our way through the different sections today.
Could I ask you a quick question? I think you might be about to answer this, but we've got a question on the chat saying, is it all coming from rivers, the litter? And actually, I'm just seeing a river. Carry on.
Yeah, so not all of it comes from rivers, but rivers are seen to be a big route of plastic and other waste out into our oceans. They're like the arteries of our land that bleed out into the seas, and they carry with it like life, kind of sediment, all sorts of things when you study rivers, but they also carry plastic pollution and other waste, and that goes out into our oceans and onto our beaches. Some of that waste is also from being blown from, people might leave litter on a beach. A lot of dump and landfill sites are relatively close to wasteland near the coastline, and often they're not covered, so things get blown over by the winds into the ocean as well. But the majority, I'd say, does probably come from down our waterways, because it's a very quick, effective way, and all rivers lead to the sea. But it wasn't until I moved to live in Indonesia, and this is a picture of one of the islands in Indonesia, that I really realised the massive issue and became acutely aware of plastic pollution. I'd always religiously recycled at home. I'd be very conscious about what I bought, but I'd never really thought about what happened to my waste once I'd put it in the bin or in the recycling. I knew there were dumps and things, but I didn't really make the connection, or it didn't hit me smack in the face until I moved to this island, which had a relatively weak infrastructure for waste management, but also had a very small area. So there wasn't really anywhere where you could hide the waste away in a landfill, away from human beings. It was there blatantly in front of you. And alongside going down the rivers, this tropical paradise that I thought I was moving to, and it still was pretty special. You can see here, this is a picture of the beach, and you get quite a lot of wood and organic matter that's brought down the rivers as well, but you also get entangled with that a lot of waste, and you can see a lot of the waste here. I was teaching at the time, as Matthew said at the beginning, and I was surprised by how passionate the students were about wanting to do something about this. They were very proud of their home, of their island, and they wanted to go out and make a difference. And so when I tried to organise a beach clean, which is one of the really good ways that we can intercept and catch that litter before it goes out to sea, I had over half the school turn up, which was amazing, but it was tricky because we didn't have enough teachers. But it was amazing. But the problem was, every time that we went to do a beach clean, and it was just about a 10-15 minute walk down the road from the school, the litter had returned as well.
Oh, sorry. Yes. Could I just pop in with it? There's just quite a few things going on the chat. So there's firstly someone saying, "Hi Sally, it's Grace," and they seem excited to say hi. This is my friend of yours. And also there's a question here from Wait saying, do you think it's demoralizing to go to these places where you can actually see the amount of plastic and waste going into the sea and building up, versus like the UK where we don't see it so much, in that it suggests to people that whatever we do here won't make much of a difference? Do you feel like that?
I'd say it wasn't demoralizing. I'd say it was actually motivating. I was quite shocked to see the amount of waste, but then also we spent an hour at the beach on this particular cleanup, and we made a massive difference. And having hundreds of students around wanting to do the same thing, and really caring about their environment, I actually found more motivating. And, not only to pick litter up whenever I see it, but to think about my actions prior to that as well. So, as I said, every time we went to the beach, the litter had returned as well. And it's not really a surprise when you think about the fact that every item of plastic that's ever been produced still exists on our planet somewhere. And so there's a problem in the system. It's not a problem that plastic is an amazing, amazing material that's designed to last forever, yet quite often it's used for items that are designed to be thrown away. And so, you need to start thinking about, right, okay, what can I do that's actually going to stop that litter being created in the first place? And I think that's one of the most powerful things that came out of the conversations that we had in being confronted by seeing that litter in the first place.
Fantastic. Sorry
So
to carry on. Sorry to interrupt you.
that's my next question for you guys. So what percentage of plastic waste is thought to be, or the majority is thought to be, single use? Is it 25%, 40%, or 50%?
What percentage of plastic waste is single use? We're getting 25 here. We're getting some. Grace is saying 50. Zoe thinks 50. We're seeing some. Yeah, generally seeing 50s coming in here.
Okay, well, they'll be right. Yeah, it is 50%. Often, as you can imagine, a lot of these figures I'm giving you, they're based on research, but they're based on data that's been collected and then extrapolated up. We don't actually have tracers and track every bit of plastic that's ever been created. But if we think about the fact that in 2015, I think there was 322 million tonnes of plastic produced. And that was doubled from about 50 years or something. Like, the amount that we're producing has dramatically gone up in recent years as we're becoming a species that has more and more of a throwaway lifestyle, looking at this single-use plastic. And it's packaging, it's bottles, it's all sorts of items, a lot of which there are alternatives for. And that's where we need to start thinking about this system. Now, something that I always thought growing up was, oh, it's fine if I use a plastic water bottle rather than my reusable bottle because I can put it in the recycling. And that is a great concept. The concept of recycling is amazing. But here's your next question. And some of you might know this because I know Matthew has done a lesson on this before, but what percentage of plastic waste actually gets recycled?
There was something I was going to ask you before as well, while people are thinking about this. When you said that 50% of waste is single use, is that the waste that's found in the ocean or the waste that's released into the ocean?
Just generally. So that statistic was generated from looking at plastic production and then doing looking at plastic waste, a lot of which was on land. I'll explain why it's very difficult to work out where the ocean waste has come from a little bit later on.
Great. Okay, cool. We're getting 15%, 10%, less than 10%, 10%. The numbers are going down as I read down the comments.
Yeah, the numbers are going down. So the latest statistic I found was that it was 9%. Now, that's pretty shocking when I've been fed this story my entire life where I think I'm doing this amazing thing called recycling, and I'm not having as negative an impact on the planet as actually I am. And it's really complex, actually, when you start to look into recycling. There's not just one type of plastic. There's 7 categories, as you can see across the top. And within those 7 categories, there are different kind of forms of plastic as well. And they have different levels of recyclability. The harder the level gets, the more expensive it is to recycle it. So a lot of our waste doesn't get recycled just because it's too expensive. But at the same time, if we take a plastic bottle, for example, every time we put that into recycle, it starts to degrade in quality. So it starts to become more brittle and hard. And as it does, it gets to the point where that plastic bottle, it's going round and round in a loop, and then eventually it just can't get recycled anymore. It's not good quality enough to be used, so it goes back into our waste system anyway. So recycling as a concept is amazing, but we haven't quite got the system right just yet, is what I would say. And we need to think more sensibly when we're generating these products of actually what type of plastic are we using? Is that plastic recyclable? And actually, if we look at a toothbrush, for example, it uses 3 different types of plastic. And so it's really hard to separate the different types of plastic from that one toothbrush. And once you mix the plastic together in the recycler as well, it becomes harder and lowers the quality too. So recycling's a very tricky, complex situation. There are some innovations in it, and I hope that there can be many more as well. Matthew, you look like you're itching to ask a question.
I was just going to say, which countries do you think kind of are doing this best? Because there are people on the chat talking about, like, is it different in different countries? And someone saying it's better in Canada than Indonesia. Like Germany seems to be quite good, right?
Yeah, I'd say Germany was kind of leading the charge a bit from what I've read. I would say no country has it 100% right, because it involves all stakeholders working together. It involves the consumer not demanding certain products. It involves industry kind of potentially not maybe making as big a profit margin by looking at using certain types of plastic or replacing plastic with other products. And it involves government as well, potentially at looking at legislations and tax cuts and how they can help the industries in actually, building a more recyclable product in the first place.
Yeah, my instincts with plastic is always just that we just shouldn't use it.
Yeah, I think recycling as we know it and as we've grown up with it isn't the answer. There are some amazing things that happen, but it tends to slow down that plastic's ultimate destiny of going into the environment anyway, as opposed to actually being truly a circular economy where it just goes round and round and round.
Did you see that thing that B. Perez said at the beginning of 2020 at Davos, that she's the head of sustainability at Coca-Cola? Did you?
No. Well, I did, but I don't remember it. 2020's lasted about 10 years, hasn't it?
It's been a long year. Yeah. No, it's one of the things in the climate course, for those who are watching who are in the climate course, where she basically does this big announcement saying, right, our big sustainability announcement is that we're gonna keep using plastic. And everyone's like, what? And her justification is that people want plastic. That's her justification number one. And the justification number two is that plastic has a lower carbon footprint than glass because it's lighter weight to transport. And you're just like, sounds really compelling, but ultimately it's just a load of rubbish, isn't it? For reasons I'm sure you're about to talk about.
Yeah, it's really difficult. I think every alternative that we look at, we're going to have some impact on our environment and some footprint on our environment. So it's about weighing up of all the solutions and alternatives. It's about weighing up the pros and cons of those, and then working out which solution works best for you in your individual context. And we can talk more about that at the very end when I introduce you to the Shift platform. So it was at this point that I joined Expedition on a voyage. So I left Indonesia and I went straight to Hawaii. And you can probably notice already in this picture that the waste on the beach in Hawaii looked very different from the waste on the beach in Indonesia. And that's because it's very close to what we call a ocean gyre, which I will talk about a little bit later on. But I was very scared. It was my first offshore sailing adventure. And we left the harbour and went straight directly into the wind. Now, there's a reason why we went into the wind. It wasn't the most comfortable journey for novice sailors, but to be able to get to these gyres or gyres, you have to sail into the wind at some point. So you're sailing into the wind, and that causes the boat to not only be on its side at quite a high angle, but you're also going up and down quite a lot. Because the waves are kind of coming and rolling towards you. So your bow, the front of your boat is rolling over them. So after we'd got our sea legs and stopped being quite so thick, we managed to carry out our scientific research. But the reason why we chose this journey and went into the wind is because of these 5 red patches you can see on the screen. So these are the gyres or gyres, and they are plastic accumulation zones. But they haven't always been plastic accumulation zones because we haven't always been producing plastic. But the gyres have always been there. There are ocean currents. And if I had an amazing interactive screen where I could draw on for you, I would do, but I'm afraid you're going to have to listen to me. So our world is pretty fascinating in the way that it works. We have a very warm equator because the sun's directly overhead. And we have pretty cold poles at the north and south, where obviously we've got a weaker sun coming in because it's at an angle to the curvature of the Earth. So that energy from the sun is spread out over a wider area. And because of the law of physics, the hot air rises and it's low density and it moves towards the poles. And then as it cools, it gets denser, and it sinks down to the poles and moves back towards the equator. to fill the gap where the air has risen.
So it's like a loop the loop. Air goes up at the
It's like
equator
a
and then down
loop-de-loop.
at the
But
poles.
it's not that simple, because our world is also spinning around on its axis. So in general, and this is a model, it doesn't work quite so perfectly as a model, that big loop that goes from the equator to the North Pole and back again, and then the same from the equator to the South Pole and back again, actually gets split into three. And as it gets split into three, it not only goes up and down towards the equator, because our Earth's spinning round, we get something called the Coriolis force. So you can see these here, and as the wind is dragging over the surface of the ocean, it kind of sets in motion this movement. And this movement's been going on for billions of years. And it causes not only that movement from hot to cold and back again, but it causes it to go round in circles. And so in the northern hemisphere, so where you've got the North Pacific here and the North Atlantic, those gyres are travelling around in a clockwise direction. Generally speaking, there's lots of links between all our oceans as well, because there's one ocean. And in the southern hemisphere, they go in an anti-clockwise direction, spinning around. And it's exactly the same as if you watch your water go down your plug hole in your bathroom, in your bath. You'll notice in the northern hemisphere, so in the UK, it does the same. It goes in the same clockwise direction in the northern hemisphere and counterclockwise or anti-clockwise in the southern hemisphere. So it's just the physics of the way our world works. But that's caused these accumulation zones to group together. And because on the currents have carried with them all of these bits of marine litter that are out floating in the middle of our ocean. And you can see here this particularly big patch in the North Pacific. Can you see my arrow?
Yeah.
Yeah. So this bit here is Hawaii, where I had gone to meet the boat. And we wanted to transect and go straight through this North Pacific garbage patch, or the North Pacific gyre. Now this is about 3 times the size of France. So we're talking a really vast area of land. And you can see on this drift computation, so here's Hawaii, we wanted to go straight through the middle. This is it building up over years and years. And obviously this is done from the beginning of plastic time, but you can see it accumulates in a tighter and tighter zone that we were hoping to sail through to get our scientific samples. And we were really surprised with what we saw. And I'm going to ask Matthew now to share the first video so you can find out a little bit more about what we saw off the side of the boat.
Okay, all. Here we go.
We've been sailing through the North Pacific Gyre for 7 days, and we can't believe what we've seen.
Plastic bottles,
toothbrushes,
Plastic bags,
buckets and barrels,
a lot of rope, more pieces of rope, nylon rope,
the constant stream of small bits of plastic,
a cigarette lighter,
fishing crates,
microplastics. We saw one huge fishing net tied up together.
seeing these beautiful dolphins and then chunks of plastic next to them.
It's the sheer amount of pieces.
It's literally a plastic soup.
Large plastic lids for containers.
A washing basket.
Half a toilet seat.
We saw a chair
With all 4 legs.
All these items once belonged to someone, and they definitely don't belong in the ocean.
I'm back. What are we looking at here then?
Oh, sorry, we started. I'm back. Hi.
Yeah.
So this is the boat in the middle of the Pacific Ocean, and we're actually in the middle of the Pacific garbage patch. Now, it doesn't look like we're floating in garbage, or as we would expect to see. It's a beautiful blue ocean when you look out over the side of the boat. And you can see here, we've got a piece of science equipment off the side of the boat called a manta trawl, because it's meant to look a bit like a manta ray, kind of skimming the surface. And it's got a fine mesh net at the end of it. We take that across the surface for about 1 nautical mile, because actually there's lots of tiny bits of plastic that form this our oceanic gyres. They're so tiny that they're smaller than your little fingernail, so they're less than 5 millimeters. And we're now going to just look at the next video. So we're going to jump straight in to the next video, which just tells you how this piece of equipment works.
All right, here we go.
We're in the very middle of the North Pacific Gyre, and when we look out at sea, it looks like a beautiful blue ocean. It's only when we put this trawl through the water with a very fine mesh net do we realise that actually most of what we're looking at right now is covered in these tiny fragments. We deploy the trawl for 30 minutes at a time, and we're taking a tiny slice, just this wide, for a mile, which just makes you wonder really how many are out here in this vast ocean. The samples we're collecting on board are going to be used for a number of things. Some will go back to Hawaii Pacific University to be analysed for the toxic chemicals that are adhering to the surface of the plastic. The rest of the samples are being analysed right here on board Sea Dragon. We're looking at pellet, fragments, film, line and foam. Once we work out what these plastics are, we can better understand where they're coming from and how to stop them getting into the ocean.
Now, you've just run to grab some samples.
Yeah, I have. So I've just shown you us collecting these tiny microplastics, and there's a really close-up image on the screen as well. And I was shocked to learn that there's estimated to be about 5 trillion plastic fragments floating on the surface of our ocean. We've got very small fragments, as you can see here, that are smaller than our fingernail. They're the microplastics. But we've also got some larger items floating on the surface. And as you saw in the first video, there were some identifiable items as well, like a toothbrush and a chair. So it is a real mix, almost like a plastic soup floating around on the surface of our seas. And once we've collected in that sample, we have to try and separate it from the organic matter. So you can see you've got in this bucket, we've watered it down through the sieve, and you can see you've got lots of zooplankton here. And we'll look at that in a bit more detail in a moment. But on this one on the right-hand side of the screen, you can see there's different types of plastic. So it's in a Petri dish. And you can see that on this bit here, you've got lots of kind of fragments of plastic. They're called secondary microplastics. And I'm going to tell you in a little bit and go through some diagrams showing you how the bigger bits of plastic, how and why they actually break down into these tiny microplastics. But we also have some primary microplastics here. Now, these are called nurdles, and these are pre-production pellets. So these plastic nurdles, or little plastic balls, are actually used in the factories to generate any plastic. So they're what's produced initially, and they add lots of chemicals and plasticizers to them to make them into different colors, to turn them into have different properties. So you've got your flimsy plastic bags and you've got your harder plastic bottles. But these ones were found out in the ocean and hadn't even reached their plastic product destiny. And then you've also got some fibers here as well. And these fibers, I've lost my mouse, these fibers could be from rope, from fishing and from kind of marine activity, but they could also be, we find a lot of microfibers from our clothing. So a lot of us now have a lot of synthetic fibers in our clothes, a lot of man-made fibers, and they actually, you get lots of them that are shredded during the washing cycle in our washing machine, and they make their way down the sewers, and they're so small, they don't necessarily get caught by the sewage treatment works, and they go right out into the ocean. So we've got a real mixture of different sources of these plastics. And it's really hard to work out where those plastics have actually come from, because we have one ocean that's joined together by these huge rotating gyres that then link up in between all the different oceans. But it is and this is where I got a bit geography teacher crazy and drew some diagrams this afternoon. In case you can't tell, this is the land and this is the sea. And then out on our sea, we've got a bottle, a bag and a toothbrush. I hope you're appreciating my artistic skills. And what actually happens is when these items are out in the environment, whether they're hanging out on beaches or whether they're out in the ocean, you actually get exposed to a lot of UV rays. And these UV rays act to start to break down the strength of the polymers, so plastics made from something called a polymer. It breaks down the strength of those, and they start to fragment and break up into tiny, tiny pieces. So earlier on, when I said that every bit of plastic had ever been made, still existed on our planet somewhere, actually, it doesn't necessarily need to exist in the form that it once was. So the bottle might not necessarily look like a bottle anymore. And in fact, if we zoom in on this bottle, you can see that the UV rays are really starting to make it brittle. It's exposed to not only the sun, but a lot of erosion and weathering action from the waves as well. So it's put under quite a lot of pressure. And then over time, that is caused it to break up or fragment into these smaller pieces. And if we zoom right in on this small little microplastic here, you can see that how this process actually happens is a bit like the onion skin weathering that you get in our natural environment, particularly on stones and rocks. And you get the UV rays breaking down and acting on outside layer of the bit of plastic. That fragments and breaks off, and it then gets to attack the next bit in. So eventually that entire piece just becomes smaller and smaller and smaller until it becomes almost an impossible job to clean up, which is why, going back to the very beginning of this presentation, when we were looking at doing beach cleans, although, yes, I do think we can do a lot to get rid of plastic and stop using it, we still have a job to do in cleaning up as well. My mum always taught me to clean up after myself, and I think that's something that's very important that we can do.
Can I just ask a few quick questions? There are some things that have come in. One of them is saying who organised the trip. That was in, I think that was the first video actually, sorry, I only just caught this question, and also how damaging is this plastic to ocean life, which I think we're about to talk about more, I guess.
Yeah, so I work for an organisation called X Expedition, and we run all-female sailing voyages carrying out scientific research into plastic and toxic pollution out at sea. So the boat you saw me on earlier was the boat I went on in 2018 across the North Pacific. But we've since been trying to visit the other 4 gyres to try and get a complete data set, not only looking at the surface, plastic on the surface, but we also know that plastic's sinking, and I'll go into that hopefully if we've got time a little bit later on. We know that not all the plastic's on the surface, some of it's sinking, some of it's even being found in the sediment on the sea floor. But obviously without a submarine, it's very hard to research that plastic that's found at those depths.
We know more about the surface of Venus than the bottom of the ocean, right? That's something that they always say.
Yeah.
So, yeah, it's really hard to do that. Anyway, sorry, to go back.
So you were asking about the impact of plastic on marine life. So having a quick look here, how many fragments of plastic can you spot in this sieve? So this is a taken photo when it was fresh out of the ocean. Answers on the chat. How many fragments of plastic can you spot? What are we getting in?
I think everyone's doing the same as me and counting. Zoe's just put in a cheeky 5,000 plus, whereas I think everyone else is probably just peering close like me. Can't count too much.
Well, let me help you out. We have
Millions,
a
says
green bit of plastic here, circled on the screen, and we also, and I've only circled 3 of them, but you were probably starting to count these fragments here. You can see they're a slightly different texture. They look a lot smoother than the organic matter, and these ones in particular are much bigger. You would get items that are smaller. There possibly are loads that we can't see, and nanoplastics and everything in here, but just picking out the ones that you can see. When I just counted them very quickly, first thing counted about 15. So there are quite a few bits of plastic fragments in there. But there's also a lot of marine life. So you can see here, as I've circled, you've got a fish larvae, or a little baby fish, that at this stage of its life, so when it's a juvenile, is considered to be part of the zooplankton, which is one of the real sources and kind of the base of the food web in a lot of the parts of the ocean. We've got sailed by the wind, little zooplankton here. Normally it has a little kind of wing attached to it that helps it get carried on just above the surface on the wind to travel around. But we also, and the most exciting thing I think on here is, we think this is a little tiny nudibranch, which I've only ever seen much bigger ones in kind of tropical waters, but we think this is a tiny little one here, or that's what we've identified it from at the moment. But if anyone disagrees, then do obviously message in your answers. Yes.
Can I just quickly say, this bit of the lesson is so cool. Wait, what? There's a plankton. Well, firstly, HM guessed that the blue bits were animals, so that's a good guess before you were talking about them. But the one in the middle, you said it has like a little sail so that it can sail on the wind.
Yeah. Oh, I wish I had another picture. I've got it being held up by somebody on a pair of tweezers, but it has a little kind of just a bit of film almost as part of it. I don't know why I now am making myself into one, but as part of it that then gets carried, and because it just lives on the surface of the ocean, so it kind of gets picked up in the wind sometimes, and that's why it's got its name from.
So
but yeah, it's
cool.
really cool, but it gets even cooler and even harder to separate the organic matter from the inorganic or the plastic items when you look down a microscope. So we've got 7 things on here. Which bit is plastic?
Okay, I've got my guess. I wonder what other people are saying. Wait, let's just give people a few more seconds to send in answers before we reveal. Okay. There's some people agreeing with me on 6. I think it's 6, and then we've got quite a few 5s coming in, but it's all about 5s and 6, it seems.
Oh, so Dr. Winnie Courtney Jones, who is our science lead at X Expedition, I have it on good authority from her that it is in fact number 7. And the reason why is the texture, and I agree 6 looks a little bit like it as well, although I was told, I can't remember what she said it was now, I think it was a little bit of cartilage from a bit of marine animal. But if you have a look at the others, okay, 3 is obviously a shell, 4 looks like a bit of kind of seaweed. If we have a look at 1, for example, is probably the clearest way you can see this. As you're looking down the microscope, you can see the texture of that particular item. You can see it's almost got cells. And that's one of the key ways of identifying plastic, is that it doesn't have that same level of texture as you're looking at it down the microscope. Now, with that in mind, I'm going to show you one more microscope picture. There are 2 pieces of plastic in it, and I want everyone, they're not numbered, so you're just going to have to try and work it out and be honest with yourselves as to whether you got it right or not.
This is so fun. I love this bit. Although I'm not doing very well.
2 bits of plastic in here.
Also, wait, how zoomed in was the last one? What was the magnification? Someone was asking.
Oh, I can't remember. Sorry. I should have written it down.
A bit. Magnified a bit.
Yeah. Right. So, what do we reckon? Do you want to guess, Matthew, seeing as there's not a number identification on them?
Maybe this is really zoomed in, right?
Yeah.
Maybe the bit in the bottom right, the bit that's most ghostly, and then the bit in the top left, and the bit in the kind of just slightly left of the middle, the really ghostly bits.
Or maybe not. It's these bits of
Whoa.
plastic. So looking at this, you can see that the others have kind of almost the ghosty bits is the kind of organic-y matter that makes them look a bit kind of slimy and fluffy, whereas these bits here are kind of much crisper, and they're actually film that's been found out in the ocean. So it's really tricky. I think we'd all agree that that is quite a difficult thing to do, to identify the plastic from the organic matter. So it's even harder for the fish and the marine life that rely on these waters and have lived there for millions of years, relying on, when it goes through the layer of zooplankton, that it's eating food. Which is why it's no surprise, and I'm afraid the next picture I'm going to show is a bit upsetting, that often when we then take fish out of the ocean and we dissect their stomachs and their digestive tract, that you can see that here we've got 17 fragments of plastic that were found in this fish. So this fish has obviously mistakenly thought that these plastic fragments were food. Now, this has it has quite a few problems. One problem is the fact that a lot of the animals in marine life die because they think that their stomachs are full. So they start to suffer with other illnesses due to malnutrition, basically. But the worst thing about this is actually these plastic particles, they attract all the nasty chemicals that are out in our oceans. So they act a bit like magnets and they absorb the chemicals. So for years, humans have unfortunately, unbeknownst to us for a lot of the time, released lots of toxic chemicals into our environment, either through industry or farming, various different things. And a lot of those are sat out in the ocean and they get attracted to these particles when they're out there. And the smaller, as the plastic has fragmented, obviously the surface areas become much larger as well. So all across these surfaces, it's a bit like a toxic soup that's been mixed together, which obviously, if that enters the food chain, it becomes a huge concern, not just to marine life, but to us on land as well. And so we've got these toxic chemicals such as DDT and persistent organic pollutants. And what happens is if they get eaten by the marine life, those toxic chemicals actually kind of get attracted once they're in the system to leach out and go into the fat cells. And then as it moves up the food chain, it does something that's called biomagnify. So it tends to become kind of magnified in its intensity as it goes up the food chain. Now, I put a human at the top here. It's not necessary, like humans have been known to test positive for a lot of these toxic chemicals. It's not 100% known that these toxic chemicals found in here have come directly from the ocean. Because it's very hard for us as humans to separate our lives entirely from our natural world. And there are lots, unfortunately, quite a few sources of these nasty toxic chemicals. But it is something that is being studied more and more. And as Matthew said at the very beginning, this is a very new kind of topic in the science world. And we're only just beginning to kind of really understand the real impact we're having, not just on the environment, but on human life as well. Even last week, I saw an article that had been released that said that some nanoplastics, so they're smaller than 0.3 millimeters, there were some nanoplastics found in human placenta. And although it was quite a shock, it has a relatively small study base, it is a piece of research that suggests that actually these plastics are making their way somehow into the human body. And we know that they've got toxic chemicals sticking to them. So it is a big concern for people as well when we're thinking about it.
Can I ask another question? Sorry, I know that you've probably got more to say and we're getting towards the end of the time. But is there, so these nanoplastics that you say have got toxic chemicals on them.
The microplastics.
And the microplastics. Could some of the nanoplastics have been covered in toxic chemicals in the air, or is that a process that only happens in the water? Feels like it would only be water to me.
So we were actually carrying out some scientific research when we were out at sea on our most recent set of voyages. So we're partway through sailing around the world. And we've done 8 voyages around the world before we had to stop. And on some of those voyages, we were also collecting some air samples to not only see for the presence of nanoplastics, but then to start to think about looking at what we're actually finding on those as well. I'm not 100% sure, I have to be honest, but I know that particles in the air, from teaching geography, I know that particles in the air have always attracted, for example, there've been condensation nuclei, and which means they've attracted rainwater. And then, if they're attracting rainwater, you've got things like acid rain. So presumably you've also got chemicals within the atmosphere as well. We know that from pollutants being let out into our atmosphere as well. They just might be slightly different in nature as to what kind of chemicals they are. But I don't know. That's me speculating, educated guess.
Cool, great answer. Yes, it feels like similar to me. It would be like this, like pollutants, but maybe smaller, lighter weight ones. But yeah, that is good thinking. But still, the work to be done. And a quick question from Ray, just saying, are there any other ways of testing or identifying plastics versus organics other than looking at texture?
There are. We have something called an FTIR machine. It's like he's seen my presentation. This is a FTIR machine, and you can see here we've got a tiny bit of plastic on it. And I haven't got a video on this, but what it actually does is it tells you the type of plastic. So on our last 8 voyages, we've been looking at the type of plastic for the particles that we brought up. So you can see here on my image, this is one of our samples from out in the middle of the ocean. And you can take each of these bits of plastic and you can put it on this piece of scientific equipment, this Perkin-Elmer FTIR, and it tells you the spectrum or the signature of that particular polymer type. And so you can identify which type of plastic it is. Even when it's been out in the environment and degraded, you can still work out the type of plastic for most of them, even if they're really tiny particles like you can see here. And that's amazing because we know that there's plastic out in the ocean. The reason why we're going out to research it is we want to find out not just how much there is, but we want to identify what type. And we want to bother looking at what type because then we want to look back on land at actually what type of plastic is used in what type of products. Are we finding a dominance of a particular type of plastic out in our ocean that's being mismanaged that we can then find a better way of managing, or we can find a replacement for, that then means that we're really focusing and using our scientific research to focus it back on land at those solutions for the waste management, as I said, but also the kind of product generation in the first place. So it's a pretty cool piece of scientific equipment. I mentioned earlier, I'm just going to quickly skim through this. We've got, this is a diagram that I found that said that actually only about all those plastic particles that you saw in all of those samples and the sample I've got here, actually those 5 trillion fragments are only thought to be about 1% of plastic that makes its way into our ocean, and about 99% is missing plastic. And so when we were carrying out our round the world voyages, so the 8 voyages we've just completed, we were also looking at the plastic in the water column. So we were sending down a contraption to 25 meters below the surface to capture the water, to then be able to see if there are any plastic particles present. And we were also looking at coastal sediments to see if we could find any plastic, because ultimately if the plastic's sinking, it's going to go down into, as you can see here on the diagram, it's going to go down to the sea floor. Now, the deep sea is too much for us because we're on a boat, so we could only carry out that scientific experiment close to the shoreline. So that's the equipment there. We did find some plastic beneath the surface. You can see there's lots of green bits on the plastic here. That's where it's actually been colonized by organic matter. So it's what we call biofouling. So here's a zoomed in piece of plastic. You can see the degradation of the outer layer, like I showed you in those diagrams earlier, where it's fragmenting. But you can also see lots of calcified tube worm coils and things like that, that is obviously adding weight to this particular plastic item. And that's causing it to start to sink down as well. It's unknown exactly whether that accelerates the process of fragmentation or whether, because it's difficult to get samples from those depths, how much is actually down there. A lot of it's speculation. But yeah, this is a really interesting picture of a plastic particle that we found out in the Pacific Ocean. And then moving to the coastal sediments, there's me carrying our very superwoman arms, lifting up some seafloor. But we were finding, this is again, I'm sorry, I didn't think to write down the amount of zoom. You can see this is from the Caribbean. We've got fragments found and lime found in those samples down in those sediments. And they're quite far out to sea. They're not on the beach, so to speak. So back to the main point, which is back on land and what we can do. So we've been carrying out some research on land to look at actually where's that plastic waste coming from and how are we managing our waste, not just in our home countries, but in countries all around the world. And something I've learned that's really important is that every situation and context is different. it's different because there are different socioeconomic barriers, there are different behaviours in terms of what people buy and how people use it and how they dispose of it. And so there has to be hundreds of different solutions, and you have to find the right solution that suits you. And it's important for all of us to take note, because this is, for example, on an uninhabited island, all of us are carrying items, flip-flops, toothbrushes, hairbrushes, deodorant cans, etc., that any of us could have used at some point in our lives. So we need to really start thinking about the alternative solutions. And one way you can start doing that is by going to one of our websites, which is shift.how. And it's got hundreds of different solutions. They've all got, as I said at the beginning, the pros and cons to each one, so you can make your own informed choices about what actually works for you, whether it's an individual looking, whether it's a business looking to try and change their supply chains or look at innovation, or whether it's governments thinking about and decision makers thinking about legislation. So it really is a real mixing pot of different ideas, and it's a really great place to start to navigate your way to solving plastic pollution.
Big fan of the Shift platform. It is amazing. Definitely check that out. I just put a link in the chat for anyone who wants to click it, open it now, and then explore it afterwards.
Excellent. And that's it really from me. There's a picture of me to show that I've finished, with all the various Twitter and Instagram and LinkedIn handles for X Expedition and myself. But one of the biggest things in there, which I haven't got in there, I think I've got the website at the top, which is shift.how, if you can see it. So xexpedition.com was the sailing organisation, but shift.how is this amazing platform where you've got all those different solutions.
Fantastic.
And that's it from me. Are there any questions? We've got time for any questions.
Oh, sorry. You just went off full camera.
Oh, sorry, I was meant to warn you.
That's all right.
My fault.
That was great. Okay, yeah, no, we've got a few minutes for questions, so do ask anything that you want. I saw that HJM asked what's the Python climb, but then that was answered by Ray, which is great. And JLTXYZ is saying, I'm sorry, I missed the beginning of this talk. Will you be giving any other talks? Are you talking about Aim High or Sally? And I think the answer is yes to both. Sally?
Yeah, I'm always giving talks. So follow me on the Instagram you've just seen. And normally, at least a day before, I put it on my stories or on a channel, depending what it is. And if you type my name into Google, you can probably find a few talks on there too.
Great. And yes, you will be about to find out about the more talks that are coming over at Aim High. There's one, for example, on Saturday at 10 a.m. UK time, depending on where you are. But there's a kind of time zone adjusted calendar that you can check out as well. Anyway, I can see a question coming in there. But I wanted to ask you one. Sorry, this is one that we've started asking all of our guests. So it's because we're starting this collaboration with the Eden Project, and it's based around this idea called the Guild of Failure. And so when we do this, we'll normally do it in kind of a bigger way, but I really want to ask you anyway, because I think it's a great question. You've obviously been doing a lot of amazing things with your life, and a lot of people will kind of look to you and think, wow, how could I get to a point where I'm having that positive an impact on the planet? And I think you're a great role model, which is why you're here. But I'm wondering, on your journey to where you are now, what would you say is your greatest or one of your greatest failures? Because I think it takes a lot of failure to get to being in a position that is good.
Absolutely. I can't pick one because there have been so many failures along the way. But I don't really like to call them failures, because I always find that when you're in a place where it feels and you're stuck and it feels really difficult and you don't know a way out and you feel like you can't do something, that's normally the place where you actually have the biggest opportunity to do something amazing, or for something amazing to come out of it, because you're pushed out of your comfort zone. And I think failure is a bit of a tricky word for me, really, because actually out of most failures that I've had in my life, I've either learned and demonstrated personal resilience and all of those kind of soft skills and attributes that kind of give you a sense of character. But I've also gone on to try and look at other opportunities that have then taken me off on a different tangent, or, you know, led me onto different things. I lived in Indonesia, so I kind of believe that everything happens for a reason in life. And actually all of those failures, although horrible at the time, and you feel like either a complete idiot or, you know, you're really annoyed with yourself, but if you're kind to yourself about those failures and, you know, reflective, you actually end up finding the right thing for you.
That was great. It made me think of you know, that Homer Simpson quote from The Simpsons where Homer's advising his son Bart, I think. He's like saying, trying is the first step to failure, and that's why you should never try.
I was going to say, I thought you were going to compare me to Homer Simpson then. I'm not sure where this is going.
But yes, no, people who don't fail aren't trying. Failure is the hallmark of trying. So what is the most impactful thing that we can do, in your opinion? So anyone who's watched and been inspired by what we've seen today, what's something that they can take away from this and be like, I'm going to do that thing? And
I think that one thing is going to be different for everybody else, but I think everyone needs to choose that one thing that they're going to change, that's going to have or make their life more sustainable. So whether they go, do you know what, actually, I do get a takeaway coffee all the time and it has a lid on it and it's out of a plastic cup, I'm going to actually get myself a coffee cup and get myself into the habit of using that reusable coffee cup, or always taking my water bottle, or, you know, if you go to the supermarket and you forget your bag, carrying it like this down the street and just kind of making a pact with yourself and a pledge that you're going to try and change that one thing. And once you start with that one thing, you'll start to realize, once that becomes a habit, that actually it's really easier. It's not made easy for us by the way our world economy works, but it does become easier to start making those little changes. And it's going to take all of us making those changes and doing it imperfectly. I'd love to say I was plastic free, but I'm not, because I almost find it impossible in our current day and age to live completely plastic free. But I'm very consciously a plastic packaging avoider. And a lot of people in my position would probably say they were plastic free. But I do think it's really important for everyone to just try one thing, change it, mix it up, give it a go, and be kind to yourself. If it doesn't work, try again the next day if you forget.
Plastic is a very exciting thing in some ways, in that we all just have such a massive impact from the really small things that we make, and also it's so easy to like shift the paradigm with people, I think, by just being really polite and friendly. When you just like politely refuse single-use plastic and you just say, oh thanks, but no plastic for me, and then maybe explain, but when it's done kindly, it just has such an impact in shifting the way that people think. Like we're about to get a takeaway because I couldn't cook tonight because we were doing this. And last time we ordered it was just so much plastic. And so today we've called them up. We're like, we're going to turn up with a load of like glass Tupperware things. So we just want you to load it in there. Which is like actually no more effort for us at all. And like small things like that make such a difference on the planet.
Indeed.
So we've got a question here saying, how do you stay so positive, Sally? Do you ever get overwhelmed or depressed about what you see? And also, because we're quite short of time, I'm going to kind of bundle that with another question, which is totally different, from Zoe saying, how much more scientific evidence do you think is needed to create real change? And that's kind of a longer question that says, it is known that we have a massive issue with plastics. We obviously need policy change, and as you mentioned, avoidance of plastic use from the source. For so many, reducing plastic use is a privilege, though, that they can't afford. I wonder what you think are the real solutions in this current system.
Yeah, and I think it's even harder at the moment with the global pandemic to try and reduce plastic, because everywhere you go, people are giving you plastic gloves and telling you to wear masks which have plastic in them. So it does become very difficult. I think there are socio-economic barriers to varying degrees around the world, and it needs to be dealt with very sensitively, and that's why we say there's not one solution that fits all, because some people can't necessarily avoid all plastic because they can't necessarily afford the alternatives. And at the moment, there isn't the supply demand to reduce the kind of in terms of economies of scale to work for a lot of the alternatives as well. There's been scientific research around for a very long time on climate change, for example, and it's still a bit of a geopolitical kind of conversation over a lot of that in terms of actually enacting change. And I think it's the same about a lot of environmental issues when you're pitching up economic benefit against environmental loss. And it's really hard, and which is why I talk about there's no one size fits all solution, but also why I talk about the various different stakeholders needing engagement and needing involvement. Yes, I agree. The more scientific evidence we have, the more likely that the decision makers and the legislation is going to act on that kind of more robust scientific evidence. But equally, consumer voice has a huge part to play as well. Even if we look at documentary TV series and education that's happened over the last few years around plastic pollution, actually everyone's a lot more aware. And even if they're not making the same decisions all the time, they're starting to make more decisions. And I always think of it that someone asked about my enthusiasm. I always think of it, if you've got 100% of people in here, there's always a percentage that are adamantly going to be against making any difference. There's going to be a percentage that have already they're in my camp, they're already making a massive difference and impact. And it's the people in the middle that are the people that are worth the time and the energy and reaching out to. But it's the people that don't turn up to talks like this that don't necessarily have access to it, haven't seen it on their particular Instagram feed because of algorithms or whatever else it might be. And it's those people that actually, they're the people that really we want to speak to. And as Matthew said earlier, just having that conversation of politely refusing some plastic and starting if someone asks you why, who's a stranger, having that conversation. It doesn't need to be rude or aggressive, but it's just reaching another person and filtering out. Because I think education is really important. Education and appreciation of our planet are really important in that.
The point you made about the people in the middle, this is one of the big things in the climate course. For those who didn't see the climate course, the idea that we don't need to focus on the people who are like climate deniers or people who think plastic is pointless. We need to focus on the people who kind of get that there's a problem, but we need to inspire that urgency. Oh, and also the other thing that I wanted to just add to what you said about the fact about, and it was also in response to Zoe's question about scientific evidence. Remember that the fossil fuel companies knew decades ago that fossil fuels were causing a massive problem, and yet they've continued to push politics in a direction that doesn't deal with the problem. And remember that plastic is mostly made from crude oil, i.e. a fossil fuel, i.e. the plastic industry is the fossil fuel industry. So that's why we have the same problem again. But we will get there. We will collapse the fossil fuel industries will collapse because they have to, or we're in just so much trouble. And that's that. Yeah. So keeping your enthusiasm up. For me, it's just we have to be hopeful, right?
Yeah.
Should we end on that?
Yeah. I mean, don't get me wrong. There are days I get out of bed that aren't brilliant, but generally I have a positive outlook on life. But I guess I'm just one of those people.
So thank you for coming to this live lesson. Thanks all, with the wonderful Sally Earthrowl. And please take some time to think about what you've learned today and how you can apply it in your own life and help to nudge things in the right direction. Everything we do every day makes some kind of difference, and we have to try to make sure it's a positive difference. I'm just going to quickly show these logos again of the Shift platform and X Expedition. Do check these things out, especially the Shift platform. Considering the global context, it is one of the greatest works of art of the modern day. I genuinely mean that. It's amazing. Go and check it out. It's kind of like, you know how TikTok is this endless scroll. If you haven't been on there, it's just like this endless, addictive, terrible scroll. Shift is kind of like that, but it's like an endless scroll of hope. It's so good. Like, you have to check it out. Yes, otherwise, please do tell your friends, family and colleagues about our Nature First, curiosity-powered online school and our mission to try to make world-class live learning accessible for all. I'll just shift over to this panel so that you can see links for a moment. Please do review us on Trustpilot if you haven't already. It makes a big difference to us if you do, and you can find this link at the bottom of our website. And if you haven't already decided to come to the final part of the Fortnight of Inspiration, then don't miss Saturday morning, 10 a.m. UK time, with ZooLab, where we'll be meeting some real-life insects and mollusks online. This final part of the Fortnight of Inspiration is very much for the whole family, so do invite younger humans along too. We are also about to announce an exciting January schedule, partly in collaboration with Education Scotland. So if you haven't already, then do join Aim High's community for updates. The sign-up form is near the bottom of our front page, and it's at the bottom of like a lot of our pages on our website. So you can find it there. And finally, we're about to launch Aim High Tutoring, connecting learners with top tutors for the price of a cup of coffee. So do spread the word about that so that we can try and make education much more accessible for people. So yeah, do follow our socials here, and do also join the Aim High community mailing list at the bottom of our website. Thank you for joining us today. Thank you to Sally for being here. Please do support the work that she, Emily Penn and others are doing. It's really important stuff. And if you'd like, I made a video about plastic pollution called Plastic in the Air that you can see if you search for that on the internet, on YouTube. But definitely check out the Shift platform over that, because that is the dream. And you don't want to spend more time looking at my face. So yes, thanks so much, Sally. Farewell.
My pleasure.
Farewell, and thank you all.
Thanks everyone for coming.
Bye bye.